Okay, so J's father, so let's call the father F. Oh, sorry. Father is twice as old as J, so 2 times J. In 20 years, so this is 20 years in the future. So this time we're not going to subtract, but we're going to add because we're going in the future. So in 20 years, J, so J plus 20 will be, is the same thing as is or was. It's just the future tense. 2/3 as old as his father. So 2/3, we multiply by father plus 20, because remember, this is 20 years in the future. How old is each now? So we're going to solve wherever we see F. This is substitution again. We're going to replace it with 2J, which is here. Oops. I was going to write J2. No, 2J. Okay. So let's rewrite this. J plus 20 equals 2/3 times 2J plus 20. So let's start multiplying here. First, I'm going to distribute. So J plus 20 equals 2J times 2/3 gives me 4J over 3. So that's what I'm going to do here. And 20 times 2/3 gives me 40 over 3. Okay, so I do not, okay, never mind, sorry. Now, what I want to do is I want to subtract 4J over 3 and move it over here. You know what? I'm going to show you an easier way to do this. If that's okay with you guys, I want to show you kind of a shortcut. If you see that there's several fractions in an equation and they all have the same denominator, all you have to do is multiply the whole thing by that denominator. Okay? And what happens is it cancels out the denominator. So 3 times J is 3J. 3 times 20 is 60. 4J over 3 times 3 is just 4J. And 40 over 3 times 3 is just 40. Okay? So now that we have this, I'm going to rewrite it over here so it's easier to see. Sorry, I don't have that much space on this. Plus 40. All right, so I'm going to minus 4J minus 4J. That gives me negative J plus 60. And minus 60 minus 60. That gives me negative J equals negative 20. This cancels out. Oh, sorry. Okay. Let me make some space here. Okay, so we divide by -1 and we get J equals 20. And we still want to find F. So F equals 2J, F equals 2 times 20, which is F equals 40. Okay. How did we do with this one? This was a kind of a tough one. You got it?
Yeah.
Okay, good. Okay. Let's do, does anybody have any questions about this actually before I move on? Okay.
I'm good.
So let's go ahead and do another one that's kind of, it's still an algebra word problem, but it's a different like style of problem. Here, let me type it up for you guys. Okay, so this is a much more challenging question. Oh wait, sorry, we have somebody coming in. So this is a much more challenging question because with this one, we have already 3 unknowns. And with this one, we're also looking at values. So let me show you kind of how to do this one. And then if you guys feel comfortable with it, we'll go ahead and try a new one, like with a practice one. I just want to say welcome to Lauren. Lauren, is this your first time in class?
Yes, ma'am.
Cool. Do you mind sending me the email you signed up with?
Yeah.
Perfect.
Do I
Thank you
send
so
it on the what app do I send it on?
You can do
Or-
it here in Zoom.
Okay.
Okay. All right. So Michael has some coins in his pocket consisting of dimes, nickels, and pennies. So he has 2 more nickels than dimes. So nickels is dimes plus 2. 3 times as many pennies as nickels. So pennies is 3 times nickels. How many of each kind of coin does he have? The total value is 52 cents. That means nickels plus dimes plus pennies. Sorry, let me rewrite this. Nickels times 0.05. No, sorry. 5 times nickels, because we're doing it in cents, plus 10 times dimes, plus 1 times penny equals 52 cents. Okay? So why are we multiplying in the third one by the number of cents that each coin is? That's what I did. I multiplied by the number of cents each coin is. And it's because it's telling us that the value of all of them is 52, which means when we add them together, we get 52. So then we have to multiply, because if the variable represents the number of coins that there are, we have to multiply by the value of that coin, okay? So first thing we're gonna do is we're going to replace this one in here. So 5n plus 10d plus p, so we replace this with 3n equals 52. So we've already replaced the p. Now we're going to replace n with d plus 2. So there's 2 of them. There's this one and there's this one. I'm going to rewrite it. 5 times d plus 2 plus 10d plus 3 times d plus 2 equals 52. Okay? Any questions about what I just did?
No.
Okay. All right, so now that we do that, I'm going to make some space because this is a mess. Okay, now that we did that, now we're going to simplify everything. 5 times d, 5d. 5 times 2 plus 10 plus 10d. 3 times d, 3d. 3 times 2, 6 equals 52. Now, I'm going to combine like terms. 5 plus 10 plus 3 is 18d. 10 plus 6, 16 equals 52. And then I subtract 16, 18d equals 12 minus 6, 6, 4 minus 1, 3. I divide by 18, I get d equals 2. Okay? Now that I have dimes, now I can find the other ones. So nickels equals d plus 2. which is just 2 plus 2. So nickels equals 4. Times equals 2, nickels equals 4. And then pennies equals 3 times nickels. We know that n equals 4, so I replace that and I get p equals 12. Okay, so even though there's 3 unknowns, all we have to do is keep doing substitution, and that's it. Any questions about that one?
Yeah, I haven't finished it yet.
Oh, okay, I'm sorry, go ahead. Any questions about this one?
I'm just getting in here, so I don't know what we did yet.
Okay,
What's up?
well, any questions from the people who did see it? Or we're okay with this? Because I know this one was a little more challenging.
Honestly, no, not necessarily. I'm just trying to see how you did it. I'm sorry. I was looking for a charger so my phone didn't die.
Oh, no, it's okay. All right, let's try. I'm going to give you guys one to do. Let's see.
Miss Nat, I'm sorry for asking you this, but do we have to write down the question or just the answer?
Whatever you want.
Okay.
All right, give this one a try. I'm going to step away for a second. I'll be back in like a minute or two, okay? Just give me 1 second, guys. All right, guys, how's it going? Are we ready?
Yeah, I think I got stuck.
Okay, does anybody need more time?
I'm ready to go.
All right, let's do it. So Marie has 505 cents in quarters and dimes. The number of quarters exceeds twice the number of dimes by 1. That's a weird way of saying this, but the number of quarters is called Q. Exceeds means it's more than, or yeah, it's more than twice. So it is more than twice dimes. It exceeds it by 1. So I know that one is like worded kind of weird, but basically this is what it means. And from the first one, we know that the quarters plus the times the value of the quarter plus dimes times the value of dimes is equal to 505. Once again, why do we multiply by the value of each coin? Because that's what we did. Well, because the variable represents the number of that coin. So to get the value, we have to multiply by the value of the coin, okay? So now that we have that, we get to substitute. Here, I'm gonna substitute with 2D plus 1 because that's what Q is equal to. So I rewrite this as 25 times 2D plus 1 plus 10D equals 505. All right, now I'm going to distribute 25 times 2D, 50D, 25 times 1 plus 25 plus 10D equals 505. So I'm going to combine like terms, 50 plus 10, 60D plus 25 equals 505. I'm going to minus 25. So I'm going to do 60.
I'm sorry.
D.
I know it's too late to be asking this. But in
Okay.
this problem, how did you get that equation where you started off with 25Q plus 10D?
Okay.
Actually,
So
no.
I got that.
I understand. Never mind. I understand how you got that. But originally, how did you get the Q equal to D plus 1? Like in the word problem, exactly how did you get that?
So that comes from the second sentence. The number of quarters exceeds twice the number of dimes by 1. So twice the number of dimes and it's exceeded by 1. Exceeds means it's more than. So quarters equals 2D plus 1.
Okay, but by 1, wouldn't that mean multiply instead of add?
Exceeds means, what does the word exceed mean?
Equal to?
No. Exceeds means more than. So that's why it's confusing, because this one doesn't have like an equals or is. It doesn't say that. It just means it is more than. Exceeds means, I know I keep saying this, I'm sorry I'm saying it too much, but in the word itself means it is more than.
Okay.
So from there, we get the plus 1.
Okay. Makes sense.
Okay. Okay. All right, good. So 505 minus 25 gives you 480. We divide by 60, and D equals 48 divided by, that's a weird 6. Sorry, I wrote it so weird. But 48 divided by 6 is 8. So now that we have that, now we can find quarters, 2d plus 1. Quarters equals 2 times 8 plus 1. So 16 plus 1. Quarters equals 17, and dimes equals 8. Okay. Any other questions? I know this one was worded weird, I'm sorry.
This
Do you guys,
16 plus 1.
say it again?
The 16 plus 1. Where did you get the 16 from again?
I found that d is equal to 8. So I took this first
Oh,
equation.
8 times 2 is 16 plus 1. Okay, makes sense.
Yeah. Good. Okay, how are we feeling about this? You guys want one more, or are you ready to do something different?
Can I have one more?
Yeah, one more just to get the hang of it.
Okay, all right, cool. So, all right. No weird language in this one, I promise. Paper contains 170 cents in quarters and nickels. There are 30 ones in all. Times the amount in each coin. Okay, so just as a heads up, there are 30 coins in all is referring to the number of coins, not the value, okay? And this will give you 2 equations. Okay, good luck, guys. You got this.
I have a question.
Sure.
I wouldn't know, well, it's not a question, it's a statement. I wouldn't know how to set up the beginning of the equation to start it off.
Okay, sure. Let me help you with that. Is everybody okay with me explaining how to write the equations? Or do you guys need more time?
No, I'm
I think
fine
I'm
with
ready.
that.
Okay, all right, cool. So first one says a purse contains 470 cents in quarters and nickels, sorry. So that means that the value of the quarters plus the value of the nickels and like the number, right? Equals 470. So it's 25 times the number of quarters plus 5 times the number of nickels. And this gives me 470 cents.
Okay, that's it. Thank you.
Okay, no problem. You're okay with the second equation?
Yeah, I think I got it.
Okay, all right, cool.
Actually, I need help with the second equation. I'm a little confused.
Okay, sure. The second equation comes from this sentence here. There are 30 coins in all. That means that quarters plus nickels equals 30. Now, what's the difference between this one and this one? This one is taking into account the value of the coins. This is just the number of the coins. Like there's 5 quarters and 10 nickels. You see what I'm saying? It's just the
So I got a
value.
question.
Sure.
Will this be elimination instead of substitution since the Q and N
Yeah.
is on the same side of the equal sign?
Yes, very good.
Okay, that's all I want to know.
Okay, remember, you guys tell me when you're ready and we'll solve it together.
I'm sorry, but I have a follow-up question to what she said. Like you said, the second equation is a Q plus a quarters plus nickels equals 30. So wouldn't that mean that you would have to put the 30 as a what would you call that? Into the equation for the quarters and the nickels?
No, so there's actually 2 ways to do this. You can use the process of elimination, which means we put the 2 equations together and we eliminate something. Or you can just do minus n, q equals 30 minus n. And then you substitute that.
Okay. All right. Thank you.
No problem.
I have a question.
Sure.
This has nothing to do with the question, but I was wondering, like, I don't know if we have anything else, like, any other lesson planned before I got here, but I was wondering if we could do like probabilities.
Sure, we can definitely do that next.
Yeah, because it's actually I'm on module 5, and like I know how to do it. It's just that when I was learning the lesson, like it didn't really show me how to do like the percents.
Oh, when it mixes them. Okay, yeah, I know what you're talking about.
Yeah, I just only know how to do the fractions.
Okay, no problem.
Thank you.
All right, guys, are we ready? Does anybody need more time?
I'm ready.
I think I've confused myself. We could go ahead.
All right, so I'm going to show both ways of doing this because some people are familiar with elimination and some were not there for that class or not here for that class. So I'll do both. So we're going to start off with elimination. We know when to use elimination because with elimination, we'll see that both variables are on one side of the equal sign, just like they are here, okay? When we see that, our goal is to find a way to get one of the variables to have the same number in both equations. For example, here, I can have n have 5 in both. So I do that by multiplying by 5. Now I want them to cross out. This is a positive. I want this to be a negative. So I'm going to multiply by -5. Okay? Now, I'm going to rewrite this equation, 25q plus 5n equals 470. And now I'm going to write the new equation down here. -5 times q is -5q. -5 times positive n is -5n equals -5 times positive 30, -150. So now I join these two together. 25 minus 5 is 20q. 5n minus 5n cancels out and gives me 0. That's the point. That's what it's supposed to do. And now 470 minus 150 gives me 0, 2, 3. I'm going to divide by 20. I can eliminate a 0 to make this easier to work with. And 32 divided by 2 is 16. So quarters equals 16. Then I'm going to solve for n. Q plus n equals 30. I replace the q with 16, so 16 plus n equals 30. I minus 16 to solve, and I get n equals 14. Okay? Now, regardless of the approach you did, you should still get the same answer, okay? So did we all get this, or does anybody?
I didn't get anything. Just did.
Yeah, on the same page. It's all good.
Okay. Did you do the substitution? That happened?
What I did was I attempted to do the substitution. Where I messed up at is when it was time to do the elimination process. I didn't use a, what do you call that? I don't know what do you call it, but I didn't use the 5n, nor did I use the 25q. I just tried to subtract the 30 from the 470, if that makes sense. Or subtract 470 from 30.
Okay. Did anybody else do the substitution thing? Do you guys want me to go over that method?
No, it makes
well?
sense of how you did the substitution now, but as far as me trying to do it on my own from a word problem, I didn't understand.
Okay, gotcha. All right. Cool. It seems like we need one more, right? Is it just me? Everybody okay with doing one
No,
more?
I'm okay with doing one more.
Yeah, I'm fine with that.
Okay. All right. Cool. Let's see. Okay. So okay, so as I'm writing this, when do we know to use substitution? I just want to make sure we're all on the same page about that.
Well, you have pennies and nickels, so I know if we have to substitute a number in for pennies and substitute a number in for nickels. And then you also say 3 times right there, so I know you have to times something to get an answer, right?
Yes, but when I say substitution, wait, let me write it out so I don't confuse anybody.
Are you talking about if it's not, the variables are not on the same side with the
Yes.
equal signs? Yeah, okay.
Exactly, very good. So we have, oops, sorry. I keep forgetting to move it over to pen. Okay, we have x plus y equals 80 and 2x plus y equals 100. This is elimination. That's when we multiply them. We multiply one of the equations to make it cancel out something in the first one, okay? When we have, which is what we just did, it's the example I just gave. When we have something like this, where we have in one of the equations, one of the variables, it's by itself on one side of the equal sign, okay? That's where we do substitution. And wherever we see that variable in the first equation, we substitute it with whatever that variable is equal to. Okay? Any questions about that?
No.
No.
Okay. All right, good. Just making sure. All right, guys. Good luck. Let me know when you're ready.
Okay, I don't know if I'm right, but I think I'm ready.
Okay, all right, totally cool. Does anybody need more time?
No.
All right, let's do it then. So Bob has a collection of pennies and nickels. If he has 3 times as many pennies as nickels, so this is a weird way of saying pennies is 3 times nickels. So pennies is 3 times nickels. Okay. And the total value of the coins is 4,160. So pennies, which is just 1, right? Plus nickels, which is worth 5, is equal to 4,160. So I don't have to have the 1 there. But if you notice something, this P is by itself. So that means this is substitution. I can substitute this with 3n. So 3n plus 5n equals 4,160. Or 8n equals 4,160. So what we're going to do is we're going to divide by 8. So I'm going to do 4,160 divided by 8. That gives me 5. Bring down the 6. 2. And I bring down the 0. 0. So this is n equals 520. Now I also have to find pennies, right, or P. So P equals 3 times n, which is just 3 times 520. So I'm going to do that here. I don't have much space, but we'll make it work. 0, 6, 15. So pennies equals 1,560, and nickels equals 520. Okay. How did we do with this one?
Okay, I think okay, I'm gonna be honest.
Okay.
The honesty is I knew what I was doing, but the unhonesty part is so I kept the 1 and left it in the problem, and I kind of subtracted my 1 from 4,160, which got me 4,159. Of course, it would have did that. So I'm like 1 number off because I subtracted the 1 from 460. Does that make sense? What I just said?
Yes, but why? Why did you do that?
Honestly, I don't know. Um, I was kind of like trying to I don't know why I did that. I don't have an answer to why I did that. It just I don't it felt like I was supposed to do that.
Okay, so what I'm going to do is I'm going to go over just kind of like what you should be thinking about, like the thought process when you look at the question, okay?
Okay.
So I'm going to rewrite this part over again because there's just like a lot around it. So it was P equals 3n and P plus 5n equals 4,160.
Okay, well I have all of that, but for some odd reason after my I meant P equals 3n, I added a plus 1 and I don't know why, but I did. But everything else was kind of accurate, but that's all I did.
Okay, so the mistake was with writing that first equation.
Right. It was with me adding the plus 1 at the first equation, and that's when I decided to add it to the second one and whatever else have you.
Gotcha. Okay, that makes more sense. Okay. Anybody else? Any questions, doubts about this, or we did okay?
One other follow-up question. When we do go to take do questions like these or whatever the case may be, will they have a place where we can insert the P and the N, or is it just gonna be one variable per answer?
It'll 520 nickels, comma 15, 60 pennies,
Oh, it'll look like that. Okay.
something like that. Yeah. Okay. Sorry, any other questions?
No, ma'am.
All right, cool. So let's go ahead and move on to probability. Is that okay with everybody?
It's fine.
All right. Does anybody have, aside from probability, is there anything else anybody wants to ask about?
I'm kind of stuck on the is this just for math or it's just for like everything that we could go over?
We can go over all sorts of things.
Well, I'm stuck on the reading, paraphrasing, whatever you call it, is when you read the paragraph and you have to answer the question at the end of the paragraph. That's what I'm stuck on. I have a lot of second guessing on my answers also.
Okay. All right. We'll talk about that then. That's good. All right. Let me put up a question here. No, you said you wanted to do the question that has the percents, right?
Yeah, like I can't like it's really like the ones on basically where you have the answer choices in percents. I was trying to like I thought it was like when I was doing it, I was doing it like you know how we normally do like percents with part over whole and all that, and I didn't. I guess the way you do it. So
Okay. All right. So what I'm gonna do is I'm gonna first do like a regular probability question. And then I will do that. I know what type of question you're talking about. I remember there's one of those in the quiz, no?
yeah, it's like 3.
Okay. All right. Perfect. All right. Let me finish writing this one. Okay. So I wrote this question, but there's actually 3 questions in it because I want to go over different kinds of ways that probabilities can be asked. Okay. First of all, when we have a probability word problem, it'll say probability, so it's really easy to spot. Okay. Second, the way we write probabilities is that we have usually a fraction. It could be written as a fraction or it could be written as a ratio. But the fraction will have a specific outcome out of all outcomes. Or another way of looking at it is out of total. Okay? Basically, that's how we write it. Okay, so what does that look like as an actual question? Well, in this one, it says a bag contains 10 black marbles, 20 white marbles, and 5 gray marbles. You pick one without looking. What is the probability that the marble is white? So we're going to go with the first question. Specific outcome, white. Well, how many white marbles are there? There's 20 of them. So we put 20 up here. How many are there in total? This is all possible marbles that can be taken out. There's 10 plus 20, that's 30, plus 5, that's 20 out of the 35. Okay? So now we're going to simplify this like we do with any fraction. We can divide by 5 both on the top and the bottom, and we get 4 out of 7, which can be written as 4 out of 7 as well. Or in words, 4 out of 7. It's the same thing. But when we're like calculating, we always write it as a fraction, so it's easy to simplify. All right. Any questions so far?
No, I get this.
Okay, good. So the next one says probability that it is white or black. So what are the specific outcomes here? There's 20 white and 10 black because it says white or black, right? So when it's or, what we do is we add. So it's 30 white or black ones out of the 35 total. Okay? We divide by 5 once again, because that's how I can simplify. That gives me 6 out of 7, or 6 out of 7. Okay? In the third one, it says not white. Well, here we look for the ones that are not white. 10 black, 5 gray. So 10 plus 5 is 15 out of 35. I'm going to simplify again, and it gives me 3 out of 7. Okay? Any questions?
No, I get it. Is it gonna be like is it gonna be like that, like the way you wrote it, like with 3 answers? Is it gonna be like that on the test, or is it like just one answer? Like, for example, the 10
Oh
black
no,
marbles.
it'll be one answer.
Oh,
I
okay,
just
so you
put
just doing
3
one.
and take advantage of the scenario and look at different kinds of situations.
Okay,
Makes sense.
Does that-
I get it.
Okay, all right. Sorry, I hope I didn't confuse you guys like that. Sorry.
No, I'm not confused. Like it was like I get the routine. Like, I get it.
Okay, good. So let's actually let me share another screen with you guys. Hold on. We're gonna look at more difficult questions. Okay, so I believe this is the question you're talking about. Or this is one example of the question you're talking about, right, Kimani?
It's really like, that the answer choices with the like for example 0.5%, or like just really like the percents.
Basically, so they're asking you to change the percent to a decimal.
Yeah, like it's like basically like because like all the answer choices right here are like fractions, but you can like number 7, like we can go with that.
Okay. Which quiz is it from? I'm trying to find the question you're talking about.
Like, okay, matter of fact, let me just I can just go and on ASVAB, because I have it. Hold on.
Okay, while Kimani's looking for that,
All right,
go
I
ahead
think I found one of these
on this
it's
one,
on the
guys.
module.
Okay.
Yes, I don't know if you remember. Yeah, I don't remember if you remember this question, but like it's the one where it says Jason is shuffling a stack of playing cards. The playing cards are a standard stack with 52 cards and 4 suits. He draws one card from the stack. What is the probability that the card he draws is a red queen? And the answer choice is like 38%, 38.8, 7.7, 0.07, like basically like that.
Okay, I'll look for it now. Give me 1 second. So while I'm looking for that one, you guys can go ahead and do this one, and that way you're not just kind of like bored waiting. Oh, I think I found it. Okay, yeah, so you guys let me know when you're done with this one, and then we'll do that other question.
I'm ready to go over it.
Okay, let's do it. So, you think of a friend to ask, you ask a friend to think of a number from 11 to 17. What is the probability that his number will be an odd number? So 11, 12, 13, 14, 15, 16, 17. There are 1, 2, 3, 4, 5, 6, 7 possible outcomes. And it's asking for an odd number. So you do 1, 2, 3, 4 out of the 7. So easy peasy. It's
Yeah.
A.
Yeah, I got that one.
Me
All
too.
right, good. Good. All right, so I'm actually going to go back to our old screen real quick. Sorry for the mix up. Okay, let me type in the question. So Jason, not Stacy, sorry. Okay, so, and with this one, I'm not writing the answer choices, but they are in percentages. So here, Jason's shuffling a stack of playing cards. The cards are a standard stack with 52 cards and 4 suits. He draws 1 card from the stack. What is the probability that the card he draws is a red queen? Well, in a standard stack, there is, oops, sorry. The 4 suits, and each suit has ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. 2 of them are black and 2 of them are red. That means that there are 2 red queens, okay? So my probability is 2 out of. Well, there's 52 cards to choose from. So 2 out of 52. I'm going to simplify this. I divide it by 2, top and bottom, and I get 1 out.
Wait. I'm so sorry. Where did you get that 2 from again? Oh, wait, never mind. I know. Never mind.
Yeah, are you sure?
I'm positive because you have your in the question it says he draws what is the probability that the card he draws is a red queen, and you said there's only 2, so that's where you got 2 from.
Yes.
Right?
Just
Okay.
to make sure, we have 4 queens. 1, 2, 3, 4. 1 for each suit. 2 of them are black, 2 of them are red. So that's why we have 2 red queens. Sorry, I know it's a little rudimentary, but I can't show you, like, I don't have a card stack to show you. All right, so back to this. 52 divided by 2 is 26. So we get 1 out of 26, but we get the answer choices, and the answer choices are in percents. But our answer that we have is a fraction. So the question is, how do we turn a fraction into a percent? We go from fraction to decimal to percent. Okay. What does that mean? First, we divide and then multiply by 100. So what do we divide? 1 by 26. 26 goes into 1 0 times. We add a decimal and a 0. 26 goes into 10 0 times. We add another 0. 26 goes into 100. Let me expand this. 3 times. 26 times 3 gives me 1878. I subtract. 10 minus 8 is 2. 9 minus 7 is 2. Add another 0. 26 goes into 220. I'm going to guess it's 8. Let's try that. 8 times 6, 48. Carry the 4. 16 plus 4, 20. Yes. So 8, 208. So 2, 1, 12. I'm going to stop here because it's going to get a little complicated. So let me make some space to keep doing my math. All right. So I have 0.038 as my decimal. Now I need to take it to percent by multiplying it by 100. There's 2 ways of doing this. You can actually multiply by 100, or you could just move the decimal over 2 to the right. 1, 2. Gives you the same thing. 0, 0, 0, 0, 0, 0, 8. Sorry. 1, 2, 8, 3. 3 numbers behind the decimal point. It gives you 3.8. The point is, it gives you the same thing. Okay. Sorry, that was messy. Okay. So our answer is 3.8%. So whenever it asks for a probability as a percentage, what we do is we first divide to make it a decimal, and then we multiply by 100 to make it a percent. Okay? Any questions about that?
No, I get it now.
Okay. All right, good. So what I want to do is I'm going to actually give you okay, go ahead and write that as a percent. When you get it, let me know.
All right, I'm done.
Okay, does anybody need more time?
Yes.
Okay, you let me know.
Okay.
All right, so you should have gotten 12%. Is
Yeah, I
that
got
what?
Yeah,
Yep, I
got it.
got that.
Yeah.
Okay. Does anybody need me to do the step by step because you got lost or?
Yes.
Okay, no problem, I'll do it. So first step, remember, is dividing the top by the bottom. So 25 goes into 3 0 times. We add a decimal and a 0. 25 goes into 30 one time. I subtract, I get 5. I add a 0 to bring it down. 25 goes into 50 2 times. Okay, now that I have 0, no remainders, I'm good. So now 0.12, I'm going to multiply by 100. So I get 0, 0, placeholder 0, 0, 0, placeholder 0, placeholder 0. 1 times 2 is 2. 1 times 1 is 1. I add them up. There's 2 numbers behind my decimal point in my question, which means there's 2 numbers behind my decimal point in the answer. So the answer is 12%. We're good?
Yeah, I
Does
was
that make more sense?
Yes.
Yeah. No, I had a question. Well,
Yes.
not but like I was wondering like can you, because I know you showed us how to do that one specific question with the card decks. I was wondering like the ones that already have like the percent in the question.
Okay, yes. So what I'm going to do is I'm going to give you one more where you have to solve the question as a percent, and then I'll do the one you're talking about. Is that okay?
Yeah, that's fine.
Okay, I just want everybody to practice this and be comfortable with it. So a stack of flashcards. Okay, so this answer it as a percentage. Okay. Let me know when you guys are ready.
Okay, I'm ready to review it.
I'm so sorry. I just realized I was muted. Okay. Is everybody ready?
Yes.
Okay. All right.
Yeah, you could go ahead and go over it.
Okay,
Yeah,
let's do it.
we're ready.
So a stack of flashcards has one of the letters of the alphabet written on each one. There are 26 in total, one for each letter. So this one makes that part easy for us. 26 goes down here, right? If a card is randomly chosen from the stack, what is the probability that the card is a consonant? So consonants are basically everything that's not a vowel, right? There's a lot of consonants, so if I go through and I count all of them, it's going to take me a little bit longer. So what I'm going to do is I'm just going to subtract the number of vowels from the total, and I know what's left over is consonants. So vowels are A, E, I, O, U, which is 5. So 26 minus 5 equals 21 consonants. All right, so now that we've done that, remember we're looking for this as a percent. So step 1, we're going to divide. 21 divided by 26. Okay, 26 goes into 21 0 times. I add a 0. 26 goes into 210. So 26 is pretty close to 25. And 25 times 4 is 100. So that means that 25 times 8 is 200. So this is going to be like 26 times 8. So 8 times 6 is 48, carry the 4. 8 times 2 is 16 plus 4, 20. So 8, 208. I'm going to subtract and I get 2. I can add a 0 here. 26 goes into 20 0 times. I can add another 0. 26 goes into 200. It's going to be 7 because I know that 8 is 208. So 7. So I'm going to stop here. So now that I have 0.807, I can multiply by 100. I get 0, 0, 0. Placeholder 0, 0, 0, 0. 2 placeholder zeros, and now I multiply by 1. 1 times 7, 1 times 0, 1 times 8. 1, 2, 7, 0, 8. There are 3 numbers behind the decimal point in my question, which means there are 3 numbers behind the decimal point in my answer, and my answer is 80.7% approximately. Okay, any questions? Okay, I'm going to take the silence as a no that this was awesome and that you're doing really great at this. Okay, good. So let's take a look at an example where the percent is not the answer, but it's actually within the question. We have to find a percent. Okay. So this next question is, Ian is at a charity dinner where there are 80 guests. Okay. So with this one, Ian is at a charity dinner where there are 80 guests in total, including himself. There is a raffle for a 5-day cruise, and Ian purchased a raffle ticket. If 25% of the guests purchase a raffle ticket, what is the probability that Ian wins? So with this one, our fraction is 1 because Ian is one person, but it's not 1 out of 80. 80 is not the total amount of people that have purchased a ticket. If he's trying to win a raffle, he's going against all the people that purchased the ticket for that raffle. But it doesn't give us the number of people that have purchased for the raffle ticket. It actually gives us the percent. So to find the number of people that purchased a raffle ticket, we have to solve the percent. So this is where we use our equation. 100 always goes here. We're looking for 25%. X goes here. And the total number of people is 80. So now I cross multiply x times 100, that's 100x. 80 times 25, 0, 0, placeholder 0. 40, 16 plus 4, 20, so this is 2,000. I'm going to rewrite it a little closer. 2,000. I divide by 100. Oh my. Okay, there we go. And this gives me 1, 2, 1, 2. X equals 20. So 1 out of 20. Now, let's put this as a percent, just, for fun, I guess, so we can practice. So step 1, we divide. 1 divided by 20. 20 goes into 1 0 times. 20 goes into 10 0 times. 20 goes into 100 5 times. Okay, so 0.05, we now multiply by 100. 0, 0, 0, 0, 0, 0, 0. 2 placeholder zeros, 5. 2 numbers behind the decimal point in my question, 2 numbers behind the decimal point in my answer. So I'm left with 5% as my answer. Okay? All right, any questions about this one?
No, I remember, like I said, I did this question, like I did it halfway right when I got 1/20, but like I said, that solving to get the decimal part after that, I didn't really understand that part, but now I do. So
Okay. Does anybody have any questions, or are we ready to just try one?
I think I'm ready to just go ahead and try one.
Okay, cool. Let's do it. All right, so Okay, and give your probability as a percent, okay? All right, guys, good luck. Let me know when you're ready.
Gotcha. Okay, I think I'm ready.
I'm ready as well.
Okay,
Yeah, me too.
cool. Okay, awesome. Does anybody need more time? All right, let's do it. So, Raphael's at a charity dinner. There are 500 guests. He purchases a raffle ticket. So he's one person out of the 15% of people that purchase raffle tickets. So we want to know what's the probability that he wins the raffle. Well, let's find out what 15% of 500 is. So we do 15% out of 500. 100 goes here, x goes here. 100 times x is 100x. 500 times 15 gives me 0, 0. 5 times 5 is 25. Placeholder 0, 0, 0, 5. And now I add things. 0, 0, 5, 7. I'm going to divide by 100. I can eliminate 2 zeros, top and bottom, right? That leaves me with x equals 75. So this is the 15%. I can put that now here, okay? Now I'm going to turn this into percent. First, I'm going to turn it into a decimal. 75 goes into 1 0 times. Make it bigger. 75 goes into 10, 0 times. 75 goes into 100, 1 time. Add another 0. 75 goes into 250. I think it's 3 times. Let me check. Yeah, 3 times. And it looks like it's going to keep repeating, so I'm going to stop here. So 0.013, I'm going to multiply that by 100. Sorry, 0, 0, placeholder 0, 0, 0, placeholder 0, placeholder 0, 1 times 3, 3, 1 times 1, 1. There are 3 numbers behind the decimal point in my question, which means there are 3 numbers behind my decimal point in my answer, and that leaves me with 1.3%.